So, okay. Is this good? Can people hear? Okay, so this is going to be kind of different because I think I would figure that most of you, like myself, really never heard of this before. And I encountered IMS, is what this is, in the process of doing some work at Cisco, and this is sort of something that I think people ought to be aware that's going on. And I'll tell you, it's a qualitatively different thing because it looks like kind of an application layer thing, and we're used to doing transport kind of things. But as we go through this, I'll try to point out where this is going to impact things if it really happens. So I'll do the goals and objectives, a little bit of an introduction and overview, and then I'll get up on my what seems to be a growing soapbox about the complexity of this thing and what it might mean. So it's an awareness-raising thing, and I don't know. I think in my experience with NANOG, there have been a few awareness-raising kind of things, but normally it's an operational forum, so we don't get this. So this is a little different, and feedback on that point would be probably useful for us as program committee. So it's awareness-raising. In 2 hours or 3 hours or 10 hours or 2 weeks, I don't think you could really understand this in any kind of deep level of detail, but hopefully you'll get some kind of idea of what it's about and what it means. And these slides, if anybody happens to want them, are out there. And of course, if you really want to dive into this, there's any amount of literature you might want to have, and feel free to contact me if you want that, or I can give you pointers. So what is this all about? Well, so I heard there's another acronym. There's a bunch of acronyms that match IMS, but IMS in this context stands for IP Multimedia Subsystem, and it's really being positioned by the 3GPP, or the Third Generation Partnership Project. These are the 3G phone people, wireless people, and it's their architecture to converge both the wireless and wireline networks, and this is kind of where it can hurt us all or affect us all, and voice and multimedia data. And as you start looking at this, you start asking, well, is it really doing that? And that's something for folks to be looking at. And basically, if you just take it to the basic level, it's an attempt to create a telephony standard infrastructure for IP that would evolve into a replacement for all of the circuit switch stuff. But as we'll see, it's a kind of a lofty goal, but it's not really near that. And then another thing to notice is that IMS itself is being proposed as sort of a wireline control services control plane. So that kind of means that even though some of us might not be in the wireless or cellular business, this could turn up anywhere if it really takes off the way that the proponents want it. So I was thinking about this and trying to understand what this really meant in terms of the kind of networking that I'm used to doing, or that I understand, because I, as many of you know, I didn't really come from a voice background, and this stuff is all being driven from the voice side. And so I was trying to find something that we all understood that had been said by somebody in our field that I could relate this to. And I remember at one of the first INETs, I don't know if this was the first INET, it was in Montreal, but there was a t-shirt that some folks had, and it was that Randy had said this: "We just build the highway, we don't fix your car." It's kind of a statement of the end-to-end principle in a way. But by analogy, IMS is attempting to build part of your car's engines, brakes, navigational systems into the highway itself, which is really something that some of us might want to look at, or all of us. And it's more than that, really. It has a billing model that's based on where you're going in your car and who's riding in it. And well, yeah, and by the way, that means that the network needs to know that. So that's a pretty frightening for us who are looking at state in the core of the network. And in short, really what IMS has as the primary design goal is to try to couple the higher layer of services that you might get, like what you get from your cell carrier, directly to the packet transport. And we'll see how that happens, but it's a design goal, which is sort of the anti-design goal for us, but generally. Oh, and then here's a little bit of the soapbox thing. That kind of coupling is one of the main places where you'll get unexpected complexity out of a dynamic system like the internet. And I talked a little bit about this on Sunday, and you can see my slide. There's a pointer to my slides. So the question is, really, what would you have to do to support this? And we'll talk about what it is, but that's the thing that I'd like people to think about through all of this talk. Not whether or not it's good or bad or indifferent, but if it were to happen, what would you have to do to support it in your transport network? So what are the kind of differences to include? Well, the voice architecture is something that many of us who haven't come from the voice side don't really map well onto the internet architecture. And you know, there are things like packet switching versus circuit switching in there that really need to be looked at. There's inbound signaling like we have with IP, and there's out-of-band signaling like you have with SS7. There's QoS and billing architectures that are different. And there's provider-mediated sessions, which means QoS and policy mediated by providers in the middle of your connection versus what we're used to, which is the end-to-end principle, more or less. Intelligence along the edges, so forth. And we can talk a little bit more about the implications of that one. And then there's the whole walled garden versus internet business model. Walled garden, where your service provider gives you a set of applications like in your cell phone, versus the internet, where it's a more open environment. And these go on, but these are a few to think about. So the next question somebody might want to ask is, well, you know, how real is this thing? Well, it's fairly real in the sense that many carriers and all kinds of standards organizations are going a million miles an hour trying to implement it and flesh out the standards. And I'll say it's somewhat controversial. And why? Well, because as you'll see in a minute, it's a fairly complex system standard, as opposed to that's an interesting thing too. It's a system standard, right? At the IETF, we don't build system standards. We build components, protocols that get put together into systems. IMS is a system. So it's fairly controversial because it's not clear how much of this stuff will actually ever be implemented and what the complexity threshold is. So there's all kinds of standards activity around this, and we'll talk about that in a second. And there's several pre-standards deployments, you know, push-to-talk, presence-based things like that. And then there's all kinds of other stuff if you're trying to figure out how real this is. People have webinars on it. You know, plug IMS into your search engine, and you'll get all kinds of stuff in there, but some of it will be related to this IMS. So when I was first doing this talk, I was kind of asking a few people from the internet side of the world, you know, what they thought about this and how this was unfolding. And one of the things that I was asked to do by several people is sort of give some of the alphabet soup. So here goes that. So I don't know. We usually think about our standards organization as the IETF, but there's a more general standards environment out there, and we generally call these things SDOs. So there's the ITU. Hey, how many folks have ever been to an ITU meeting or ever read an ITU document? Really? That's quite a few. That's quite a few. That's interesting. How about 3GPP? That's a little less. Okay. And then there's 3GPP2. Okay, this goes on forever. There's ETSI. There's ADIS. I mean, this just goes on forever, right? So this is also a plug. If you can't find a standards SDO to work in and you're a service provider who wants to participate, come on up and we can like find one with the right set of letters. There's plenty of them. Oh yeah, and of course there's the IETF. It has something to do with this. So more, IMS is the intermediate IP multimedia subsystem. So I'm going to give you a couple of these because there's a lot of terminology in here that's not familiar to me or wasn't, at least when I started, and definitely isn't to the rest of us, I'm sure. But this thing is a pretty important component. You'll see how it works, but it's called a CSCF is a call session control function. And there are various types of these, and we'll see in a second what they are. But basically they're like SIP proxies, and they're like session border controllers and things like that. So, and then there's a home subscriber server, and that kind of replaces the what were called home location registry and visited location registry in the mobile world. And then there's all these other standards that I don't know if anybody has a phone that they can do networking on, but GPRS is what T-Mobile has and what AT&T has, and that's something like that's also called 2.5G. And this has a bunch of components like GGSN, which are gateway things. Just think of them as gateways on and off their network. And in IMS, this thing called PCSCF, which is the proxy, a SIP proxy-like thing, is the first thing that you hit when you're using the system, and it has to be in the same network as this a GPR signaling node. And that seems like a minor thing, but you'll find out that when when you're trying to implement the cellular roaming model on top of a packet-based network, that becomes a huge requirement and constraint. And then there's all this radio language, 3G radio, 2G radio. So there's GSM, which I think most of us know about. There's UTMS, and there's UTRAN. These are kind of what's coming after GSM. And so what is all that stuff about? So I tried to make a graphic of this. I don't know if this is going to work or not, but does that work? I don't know. Can anybody read that? I think the important thing to look at is, this is sort of the complete thing, but the important things are in 2.5G and 3G, the data rates are we sort of miss the data rates in both cases. So it's something to think about as to why that might have been. So 3G was supposed to have up to 2 megabits, and it's really got something like 64K right now. So what does it mean for the rest of the wireless landscape? Well, it's kind of like this. The 802.11 stuff on the low end sort of lines up with 2G, 2.5G, and 3G, and then above that we don't have anything that's really being standardized in the voice on the cellular side. Although there is, I don't know if it's on this picture, but there's a standard, growing standard called UMA, which is sort of voice over 802.11. So let's get into what IMS is. So that's a little bit about a quick view of what's going on out there in the phone world, and it's obviously there's a lot of stuff going on, but I'm trying to get to the stuff that's going to impact us. So there's some major features in here. First off, it's interesting because the wireless networks really are all transported on terrestrial networks, or usually called public land mobile network. It's not that the network's mobile, but it's providing that transport for the mobile pieces of the cell system, and that's called a PLMN, and you'll hear that a lot. And it's divided into core and access networks, like every network almost. And the access network is generally the radio, the radio area network stuff, which is not really much of our concern generally. And then the circuit core network has a circuit switch part and a packet switch part in IMS. So this is how their architecture works. Well, the interesting thing is legacy voice, which is all voice really, is still in the circuit switch part of the network, and I'll show you how that works, which is kind of a surprise, because you'd think that if you were building an IP multimedia subsystem, you would do voice over IP on voice. Well, there's a reason for that too. But basically, IMS is all the core network elements. So it's kind of like a services control plane, some kind of policy engine, and some kind of AAA. And generally, the services control plane is all SIP based. And the policy is either COPS. These are protocols developed in the IETF, or SOAP-B. And I think that COPS is, I think 3GPP just met last week, and I'm not sure what the status of COPS is. Does anybody happen to know that? I think it might have gotten downgraded as a possible policy language. And then radius and diameter are in play for AAA. Okay, IMS also gets these domain ideas lined up in this way. So there's a circuit switch domain, which really is the circuit network. There's a packet switch domain, which is really kind of the internet-like piece of it. And then the IMS part of it provides policy, services control plane, and AAA. So this is kind of what it looks like. And 3GPP is really where IMS is going to, if it does fly, where it's going to fly. So it kind of looks like this. So there's some underlying models here too. First off is walled garden. Is that a term familiar to people? I wasn't really familiar with that term. Anybody heard that term before? Oh, okay. It's sort of a business model term. But the whole idea here is that carriers are trying to avoid what might be termed a bit pipe syndrome, where transport, the perceived commoditization of transport. By the way, if somebody could figure out how to make a good living on transport, that would be big. It has some other things. Every SIP packet in this thing is inspected by at least one of these CSCF devices, which is, I don't know if I have that here, but yeah, it's not exactly what we think of as the end-to-end principle. And you got to think about what kind of storage, maintenance, state might be required to actually do this for every session in the entire internet. So there's a holy grail out there too, which is one platform, many services. So IMS would be thought of as a platform that people could launch all kinds of services on, like presence, availability, push to talk over cellular is being called POC. I guess PTT was taken. So push to X is out there too, where X is, show, voicemail, peer-to-peer stuff, instant messaging, and eventually all this wireless wireline integration. So what does all that mean? Oh, dual mode. Do people know what dual mode voice is supposed to be? This is the idea where, okay, I have a phone that's, say, quad band GSM and 802.11, and I could just walk around and it works and takes the best connectivity wherever I am. So if you put all this together, the kind of schematic view of this is there's a circuit switch domain, as I was saying. So you have this radio area network. Here, maybe this will work. So the radio area network stuff is right here, and that's like just an access network. It just happens to be radio area. Voice, legacy voice, which is all voice right now, goes this way, and it's all circuit switched. It's the old circuit switch infrastructure, and then they just dump it onto the PSTN wherever they do. And this is all where the packet networking that's related to what we do is going to happen, all in here. And so it's all controlled over here by IMS. So the idea is that you have this subsystem that's controlling all of this stuff and mediating every connection in this. So let's see how they might do that. So here's the problem. Anybody ever seen any of these pictures that come out of like ITU before? It's kind of interesting. They build architectures, and those of us who have come from the IETF, we really don't build architectures. We build components that can be used for architectures. So these kind of pictures are a little bit less than familiar to us, but what I will point out is that all of the boxes get called out, and all of these are functional entities in the architecture, and then every interface is defined and has certain properties. By the way, one of the reasons why voice is still circuit switched is because this interface, well, if you look on here, I don't know what it's called, maybe UU or UM, those interfaces aren't efficient for packet transport of voice right now because they were designed before then. So what you wind up with is this, it's really hard to look at this and say, oh, okay, I see how this works. But what you wind up is a pretty complicated system. Well, some people do. Some people can look at that and go, oh, okay, I know how that works, and tell you how all the signaling works. But basically, these are all SIP signaling paths in here. So, there's a lot of signaling that has to go on to make this happen. And, that'd be a whole day in and of itself. See, okay, that was the architecture view. Okay, so you have that architecture, and, to really understand that would take all of us a long time, or at least it took me a long time, and I don't think I really fully understand it. But what I did do was, when I was looking at it, I realized it makes some assumptions that make the ability to make it simpler. It has a certain kind of irreducible complexity if you're going to implement this model. And this is what I wanted you folks to really look at and think about. So if you see this coming down from wherever it might come down from in your organization, that you could ask some questions about it. And so it kind of has these three aspects that can't be really simplified if you want to implement a model like this. One is roaming, and it has actually the same roaming model as the cellular system does. But we'll talk about that in a second. But that means something different for us in the packet networking than it did in the wireless world before this. It has PERC session QoS, which is something that I think we've kind of rejected, or at least rejected in some ways quite a while ago. And then it has this coupling of higher layer services and packet transport, just like the cellular system does. So we'll look at each one of these a little bit. Oh man, I gotta hurry up. Okay, so what is roaming in IMS? Well, basically, you're roaming if you're using packet network resources, not circuit switch resources, but packet network resources in the network you're visiting to connect to your IMS at your home. So it's really that you start roaming when you're using any packet networking resources in the network you're roaming on. And that implies, which is important, that this proxy CFCF thing and the GGSN, which is sort of the gateway to the internet thing, only those two things can be in the visited network that you're visiting. That's a big constraint on the whole system. And it also means that the subscriber, so you got to think about how this might work. You fire up your phone and you want to look at the web. Well, you have to send some SIP signaling through this PCSCF and all of this stuff back to your home network, which then triggers all the policy stuff, and that gets installed in the whole network on the way back. So there's also, well, this is kind of another thing. IMS invented, well, actually 3GPP invented their own form of mobile IP, and it's called the GPRS tunneling protocol. And enough said, they have their own mobile IP. And then there's something called interworking, where two of these IMS networks are interconnected by another one, and the other one enables the control plane to work and the transport of the user data plane. So the picture kind of winds up looking like this. A is kind of roaming. Actually, I think this picture is better to show you that basically all services in IMS you get from your home network, even when you're roaming. So the main point here is that even when you're roaming, you have to go find your home network. Your home network has to install policy, and that has to go back through the whole data plane, which actually is the control plane, back to actually has to follow the control plane back to wherever you're at. So there's a lot of complexity here in the roaming picture. But if you want to break it down to something a little easier, which I did because I couldn't really understand it for a while, is that they're basically the subscriber binding to the home service network, which requires that the provider mediates the roaming. In other words, everybody has to know where you are, right? Like if you take your laptop and walk over to your neighbor's house and sit down on their wireless and DHCP an address, that's the only state in the network that's there. Not everybody along the path from your neighbor's house to wherever you are. Well, this requires that everybody in the path from your neighbor's house knows where you are. What it means is that the scheme really requires 6 parties to coordinate. This is just to get a connection up so data can flow. And there has to be at least 3 billing and accounting relationships. And all of them have to be tracked in the control plane, the data plane, and the management plane. Now you got to think about that, because that doesn't mean just within your network. I mean, that has to happen across whatever peering turns out to be for this. So wherever the settlements are resolved in this, that has to live across that, and I'll tell you what those are. Which are they? Well, let's see. So let's look at that for a second. 6 parties to roaming. Well, obviously, wherever the sender is, the person who's sending has to be involved. The person who's receiving has to be involved. The home service provider of A, remember, that's where all the policy and everything comes from. The home service provider of B, likewise. Whatever provider the sender is currently roamed on, and whatever provider the receiver is currently roamed on. All those things have to be tracked through the control plane of the thing. Accounting and billing relationships, well, the sender with its home provider, obviously that's the commercial system. The receiver with its home provider, again, that's the commercial system. The provider of A with the home provider of B, right, the sender and receivers, if they want to implement things like closed groups like the phone guys like to do. The home provider of the sender with the provider that the sender's roamed on. I mean, this has to be a roaming agreement between those two. And finally, I think this is the last one, the roaming agreement for the receiver. So if you think about that, all of that stuff has got to be tracked in the control plane of the end-to-end connection state of the network. So that's a lot of stuff, and we don't really do that right now. So the key takeaway of all of this is that if you want to implement this roaming model, that's sort of an irreducible piece of complexity, and there's just no way to get around it. So the other one, what's next? Well, there are 2 more. So IMS has this per session QoS model, and we went around the per session QoS, the per flow QoS quite a bit when I first came into the IETF. Well, the phone guys do have per session QoS because they have a circuit switched network. They want to have the same per session QoS in this network. And it turns out that the policy has to be mediated by every service provider who has an accounting billing relationship on the signaling path. And the data is constrained to follow that same signaling path. And that's a major source of complexity if you think about what you'd have to do to maintain that in your network. Okay, so if you combine that with the roaming model, you get something that's pretty complicated, and really the desire here is to replicate the billing behavior of the PSTN for end-to-end flows, right? Because when you put up a phone call, it's an end-to-end flow, right? Same thing. So the system has to simultaneously enforce 3 invariants to make that happen. What are they? Well, let's see. and you got to think about this, because where does the state for this reside? Remember how much work we've done to keep our core kind of stateless or minimize that. Where does the state for this stuff have to reside? Okay, first off, the destination subscriber is not alerted unless the QoS are available for the call, right? For whatever the thing is. Well, that's like saying, okay, if I pick up my phone and I can't make a phone call, I'm not going to ring your phone anyway. You don't get billed until the destination subscriber answers. Well, that's kind of like the phone system too, right? You don't get billed for that. And QoS can't be obtained on the transmitted data until billing starts. Now, what does this all mean? Well, the real thing is that if you just leave the state aside for a second, it requires this reserve commit phasing and signaling, which we don't have either. You know, we're working on single-sided signaling and things like that to reduce this kind of dependency. This is putting a heavy reserve commit phasing requirement on the signaling, and it also, well, let's just put it this way. There's been a lot of extensions to SIP made to make this happen or make it easier to have it happen. So there's a lot of operational complexity here. So it's two-sided signaling, right? And the picture is really complicated by the fact that the services, which is really the point of IMS, right? It's to provide, to build a service creation platform. The services that are there really exacerbate this situation, like toll-free, reverse charging, prepaid. That's really tough to do. And again, the point of this kind of awareness raising thing is just think about what you'd have to do in your network to support that kind of state. Well, appearing. Okay, so there's another coupling thing here too, which is the third source that I could identify. And basically what's happening with okay, 5 minutes, okay, yeah. So like I'm going to talk about IMS in 20 minutes, and it's worth a try. It's worth a try. So this is the last one, and the thing here is that the whole point of this is to couple services to the transport layer, just like the cell system does, or just like the voice system does. But we have in the packet world or in the IP world, we've done all this work to do the reverse, right? So specifically, the complexity really derives from trying to couple services, billable services, to the QoS and packet transport, and that's what's really causing this to go out of control. And let's see if I can just get through this. Okay, well, this is some of the business stuff, and basically what it is there's three motivations, right? Leveraging assets, obviously everybody wants to do that. Cross-subsidizing, because that gives everybody price flexibility. And then the whole idea of dampening, you know, the walled garden idea, dampening price-based competition. So all of this stuff is encoded in all of the IMS stuff. So I just want to show you one other picture, which, because we've got to go through here quickly. Oops. Okay, so this was the kind of the roaming thing, and then your network, you might not even be involved in any of this IMS stuff, but all of a sudden you're what's called an inter public land mobile network. And you know, you're sitting here in between two of these guys doing this. There's a device that goes here, and you could use IMS terminology, but you could also use, how many people have heard of session border controller? Well, that's what goes here. And you might be stuck with session border controller even though you don't have an IMS. So the point of this whole thing is not to give you a tutorial on what IMS is or how it all works, but basically, if you see it coming along, think about a little bit what your network's going to have to do to provide this kind of service, and what you need to tell your management about what you can really accomplish. Because, as I said, there's some controversy over IMS, but there's a lot of people who are implementing big chunks of it. So I'll just leave it at that, and maybe I have questions. Do I have any questions? Too much stuff. I know this is a little bit of a different NANOG talk.
Well, I actually love this talk. This is a great talk for me because it seems to be addressing one of the problems that I have on my list of problems I want to solve, and I can tie it directly in my own mind, but of course I don't speak for operators, which is why this might be a clueless question, but your conclusions aren't that like provocative. Can I just ask you, is this going to work? Do you think this is going to work?
So, okay, good
is
question.
That, I mean, is that a fair, I mean, you can measure the audience like I always do and blame them for the wrong answer.
That's a fair question. No, that's a fair question. I tried to not be too provocative because there's a lot of controversy around IMS, and I wanted people to form their own opinions. I wanted to kind of see if I couldn't distill out what I thought were the aspects of IMS that were going to clash with the Internet Protocol, our model. And so if you want my gut feeling about whether or not this is going to work, a lot of people ask me that. That's the first thing. And I think, like Milo once said, I think, is that, if you put enough horsepower behind it, some piece of it will work. Whether or not it's going to deliver what people really want, which is, holy grail, I got a service creation platform that I can build any kind of service rapidly on that lowers my OPEX and CAPEX, I don't think so. But that's just my opinion.
So I'll just give the audience the benefit of 10 years of work on QoS in the research community to try to accomplish the same stuff, which is that we've abjectly failed. And we freely admit that, even, the leaders of the community. Interdomain QoS, before I watch all these shaking heads. I understand Cisco's got QoS working in enterprise networks and all that, and I don't mean to delegitimize the benefit of that. But interdomain QoS is what I think this thing is about, right? Among other functionality. And so, again, I think this is exactly what I hope the community is talking about. But the reason that the research community failed to do anything useful with interdomain QoS is because we basically completely ignored the problems that are at the root of QoS, interdomain QoS, which is economics, ownership, and trust. And I just don't see how this is addressing those problems. So I want to be wrong about that because I'd love to see those problems addressed, but I wonder if you guys think the same roots that we figured out are the same roots.
Yeah. I don't think it's explicitly addressed in the IMS work because the just addressing the interdomain thing right now, the interdomain QoS thing seems to be has come back. I don't know if you're aware of this, but I mean, there's a lot of activity around interdomain QoS right now, just like there's a lot of activity around interdomain MPLS stuff, right? So I don't know. I think that's being kind of looked at again, but not by the 3GPP people who are building this. So as far as the interdomain piece of this goes, I agree with what you said, but I still think that I think that it'll fail before that in some ways, is what I'm trying to say, I guess.
Great.
I think there's weak links that will reach before we get to the human factors part about not being able to deal with settlements and all of the different things that we'll have to do.
Okay, and then a related question, which you made an off-the-cuff comment about how it'd be nice if we could figure out how to do packet transport in a profitable way and make a living at it. And again, I wish I knew more about this, but I don't know any provider that says that backbone transport is profitable right now. So this is sort of just putting that question under the rug, right? Or are they owning up to that problem?
No, I think everybody's aware of that problem, and I think IMS is sort of a response to that because the normal response to that we've seen is go up stack because there's more revenue there with better margin, right?
But does it make the lower part profitable, or just it's a lost leader now?
Yeah.
Okay. Anyway, that was a great talk. Thank you.
You're welcome.
So, to disagree a bit with you guys, first with KC.
Who are you disagreeing with?
Both of you.
Oh, okay.
First with KC, I think interprovider QoS works great today. It just doesn't work internet-wide. So there are plenty of providers that have bidirectional relationships where they have private interconnects with their agreed-upon QoS. It's working. It's deployed. So internet-wide is probably not a goal even.
I think you have to define what internet-wide means as well, because I think that's where this is.
It is working today for those levels.
And there are also several consortia on top of that, right? I mean, on top of that, basically IDQ, interdomain QoS problem.
That stuff. Interdomain QoS is deployed and working for services for which there's money on the line to pay for that QoS. But back to your presentation, I mean, the QoS...
Is this the part where you're going to disagree with me?
Yeah.
Okay.
The part about... I think what we should do is try to figure out how to make it work, not so much question ourselves, is it going to work? I think if there's a business drive, our job should be to try to make it work. For instance, the per session QoS, if you encapsulate it in a core in terms of trunks, which is what the ATM guys and the phone guys have always done across the years, I mean, you can make per flow QoS work simply by using layering and learn a bit with what the ATM types did. Your comparison regarding the roaming stuff. I mean, the mobile IP model also uses home agents, foreign agents. So if you did the one-to-one comparison, you'd have the same thing. So from your complexity analysis,
Not really. Not really. You know,
I'd like to see that.
Yeah, we could get into it, but it's not really the same.
So from a complexity,
Let me just make a point. The point I was trying to make is, Susan, am I running on? Okay. The point I was trying to make there, and I probably didn't make it clearly, is that you could do this in two ways, right? You could say, all right, I have a packet network, and what I'm going to do is I'm going to build services on top of a packet network and build applications that are packet network aware. Or you could say I have a packet network and I'm going to try to make the infrastructure I had run over that. And see, that's what the latter is what IMS is doing. And in fact, it's doing it at another level, which is that the circuit infrastructure that people are you know, in the circuit switch domain of this, which was the circuit infrastructure they had before, the PSTN infrastructure that they had before, what folks are wanting to do is just lay that all over some pseudo wires and then lay IMS on top of that, so none of their operational infrastructure has to change. So it's even more than just IMS.
you need more than that. I think the best thing we could do as a community would be, instead of asking ourselves, is it going to work, sort of ask ourselves, what should our contribution be so that it works better?
Definitely.
If you remember correctly, last time, you know, a few years ago, people were talking, oh, L3 VPN, L2 VPN services on top of IP networks, and a bit of reaction of the community was saying, oh, it will never work. It is working.
Yeah.
So I think it would be good not to repeat the same mistake.
Yeah, definitely. Yeah. I think the complexity analysis I wanted to, Spencer, I'll get you in a second, okay?
Yeah.
The complexity analysis was supposed to be something, was supposed to tell you something like, if you want to do this and you want to make it work, you got to pay this price. Not that it will work or won't work, but there's just an irreducible amount of stuff in there, and you can't get below that, especially, and the roaming model one is the one that really comes home easily. So that's kind of what I was trying to say there. Go ahead, Spencer.
Yeah, Dave, I just wanted to thank you for doing this talk. It was very helpful, and I think it dovetailed very well with what you talked about on Sunday afternoon about complexity. Can I back you up to your last picture that had the "you are here" at the top, basically?
If I only knew how to work my laptop, I'd do it.
Okay.
Hang on. I like Magic Point, but it you know, it has its quirky things. Oh no, I did it again.
Yeah, that one there. So basically, I two questions. One is just a clarification. You're saying basically that even if people in this room are ending up in the, I guess, the second box from the top,
Yeah.
that with the per flow QoS that IMS is talking about, that they're going to have some awareness that they're transporting that stuff?
It's possible, yeah.
Okay.
That was the red flag on that one, exactly.
The other thing I just wanted to mention is, you know, you talked a little bit about session border controllers, and I think there's just a huge number of issues that the community doesn't have a clue, and I mean the SIP specification community doesn't have a strong understanding of at this point with SBCs. One of the things was we're doing a lot with voice QoS, again, voice over IP with mean opinion scores and things like that, which is working fairly decently because everybody's dumping all their voice over IP traffic onto the circuit switch network at the edge of their network. But this is talking about, you know, you'll stay packet switched all the way through this.
Okay.
And so basically, if you're terminating the bearer traffic at 2 or 3 points, you can have acceptable R scores on every leg, but not, you know,
MOS, you're talking about MOS.
I mean R factor and MOS scores on every leg, but still not have something that works for the customer end to end.
Yep.
And nobody really has visibility to that because you're talking about, in this picture, you're talking about potentially 3 completely different networks with 3 different administrators.
Yeah, how many networks do your packets go through between any 2 points, right? There's somebody over there. Can we take that one?
Again, I'd also like to thank you for the presentation. I think it really helps to to point out to people that there are things that can happen that are too complex. And I think that we can look at this also as, what is the goal of the network? Is it to, make sure that old companies can continue to make the same kind of profits, or is it to be able to let people have content and all the benefits that the internet does? This kind of network is really an anti-internet, and it breaks the end-to-end principles. It's also, from an implementation point of view, it's kind of like ATM cubed or something. I think that what people might want to look at is the concept of the paradox of the best network, because I think that's really what we're fighting with. Is if the issue is that bit transport doesn't pay, we need to figure out a way that we can still transport bits. And people can look at netparadox.com to see more discussion about that.
Thanks. Travis.
Dave, thanks, pal. One thing that has to be clarified is that IMS is not totally finalized yet. It's still like a moving target.
Yeah. Yeah.
So,
Yeah.
no,
Yeah.
but people are making products for it and trying to sell them to us.
Yeah, and there's several pre-standard deployments that are.
So network operators really have to get involved now before we get this imposed on us by, unfortunately, someone who has an idea that the SS7 network should be imposed on the internet. So
A lot of those people.
yeah.
So it's a good point, Travis. I didn't put my final slide for my other talk, which is sort of kind of trying to get folks to come out to the standards organizations, SDOs, whichever one you like, because these people are building this stuff and it's going to affect you, and you're the folks who have the real requirements. So any way that we can get more operator participation in either the IETF, ITU, wherever.
Yeah. So rather than just consuming these standards, let's try to set them, because something like this with so many moving parts, with so many interdependencies, does really anybody here want to add that to their network?
So Dave, I want to thank you for
I'm
an
done.
excellent
Okay.
talk.
Thank you.
So, I actually had one technical.
Oh, you did?
Yeah.
Okay.
The question is, do they have good examples of trying to strip down some of the functionality of the per session QoS? Do they have to have all, or can they have some of that in order to make their billing and their callback stuff work?
So,
Because complexity reduces if you can do that.
Yes, definitely. There's several pre-standard deployments, and they use different infrastructure to accomplish pieces of the same thing. So the answer to that is yes, but they aren't IMS. They're pre-standard kind of policy control planes.
Would you be willing to post or give us some examples or some further on about
Yeah, definitely.
that subsection?
Sure, definitely.
I'd be interested at least. Thank you again.